Hi, and welcome back to part 2 of trigonometry, part 3. So we're going to be talking about integration of trigonometric function. So let's quickly recap what you've learned in integration in last semester. In integration, you learn integration by substitution, where when in a function, you have f(x) and f prime x dx. So this is where you're going to take out f prime x dx and make it equals to u. You're going to let u is equals to a certain function. You're going to differentiate du over dx is equals to that function, and you're going to replace that into that function. And another one that you've learned during integration last semester was that integration by parts, where you're going to identify u dv, and that is equals to uv minus v du, the integration of that. And how do you select your u and your dv was according to low pat. And the last one has always been trigonometry. So we're going to use all of that knowledge and we're going to bring it into this this chapter right here. But we're going to skip all this and go straight to the applications of what you've learned in integration, which was area and volume. And this volume is going to revolve about and exist. So straight to the lecture. You're going to find the area of a region bounded by the curve and the axis by two curves, and a volume of a solid of a revolution that revolves completely about an axis by two curves or any line parallel to the axis. So let's start with a simple example. This curve right here, it starts from 0, its maximum point is 1, and it ends at pi. This tells you that this is a function of sine. So we're going to find the area enclosed by the curve and the x-axis. So that means this one right here, that is being lorec, okay, from 0 to pi. So this is obviously the integration of sine x dx from 0 to pi. So the d, previously you learned in the first part of the lecture, the d dx of cos x is equals to negative sine x. But right now, since the integration is the terbalik of the differentiation, right now you have sine x with no negative right here. Okay, so if you were to integrate sine x, you are going to get the negative of cos x from 0 to pi. So getting negative cos x from 0 to pi, put in 0, and you should be able to get your answer. Make sure they are in radians. Next example, now you have to find the area of the shaded region from 0, x is equals to 0, to x equals to pi over 4. So this curve is given as cos 2x dx. But right here, you're going to have to use substitution. That means you're going to let u is equals to 2x. Therefore, the differentiation of u, the du dx is equals to 2. But there are no 2 right here. So that means du over 2, bringing the 2 over, is equals to dx. So you're going to get a new integration of cos u 1 over 2 du, which results in sine u over 2, but u right now is equals to 2x. That's how you got sine 2x over 2 from 0 to pi over 4. Substitute those values in and you will get your answer. Now, next graph. The graph shows part of a curve y is equals to sine x cos x. Find the area of the shaded region. That means the shaded region is from 0 to 3 pi over 4. So just quickly integrate that. Okay, the integration of sine x would give you negative cos x. Okay, and the integration of cos x would give you sine x from 0 to 3 pi over 4. Put in those values and you quickly can get your answer. This is correct to two significant figures. Okay, find the area enclosed by the curve y is equals to 3 cos 2x sine 2x. Okay, so again, you're going to have to use substitution. Let u is equals to 2x for just cos 2x. Okay, then separate sine 2x. So over here is a typo. Okay, this one is also supposed to be 1 over 2. Then you add in those values. Again, there should be 1 over 2 here. And also another 1 over 2 here. So then no identities needed. Okay, and you should get your answer. This is not in its fully simplified form. Now, what if you have areas enclosed by two curves? One of the curve is sine, which is the blue one, and the other one is cos, and it is bounded by the x-axis here. So that means you're going to have to integrate from 0 up until pi over 4 using sine x, and then from pi over 4 down to pi over 2 using cos x, and then you plus the area together. For example, this is the first part where you are integrating sine x from 0 to pi over 4, and then you integrate cos x from pi over 4 to pi over 2 to get the second area. Plus them together, and then you will get your final answer. Now, let's go straight to volume. Okay, so the volume of solid generated by revolving around the y-axis. Remember, when the volume is generated about revolving it about the y-axis, that means when you integrate, your limit of what from a to b is going to be in terms of y, your integration must also be in terms of y. That means your function here must also be in terms of y. So right now your function is already in terms of y. Your limit is from 0 to 1, which is on the y-axis. Okay, and now we're going to integrate that in terms of y. But remember, when you are dealing with volume, then you have to add pi in front there, and you're going to square the whole function. Like this one right here. So everything would be in terms of y. Okay, but the problem is right now that, oops, the problem right now is that this right here is tangent squared pi over 4 y. If we quickly recap the differentiation of what could give you tangent x. Tangent x alone or tangent x square. If you check your formulas, none of it gives you tangent. So that's why this would be a problem. Okay, so option 1 would be to change it into sine x over cos x, the whole thing square. But this then would result in more substitution, because then it's a fraction. So it's bigger to deal with. You have to do integration by parts, or substitution first then by parts, which results in a longer way. So second option would be to realize that if you differentiate d dx of tangent x, you would get secant squared x, and that tangent squared x plus 1 would equal to secant squared x. This is one of the identities you have learned in trigo part 2. So we have tangent squared x, okay? We can definitely change it to be in terms of secant squared x using the identity. So that is just what we did. We changed it to be in terms of secant squared x. But mind you, right here is a function on its own. So you're gonna let u to equals to pi over 4 y. So that means that du over dy is equals to pi over 4. So that means that 4 over pi du is what dy is equals to right now. So dy is going to be replaced with 4 over pi du. Then integrating secant squared, u would give you tangent u. So u right now is pi over 4. Replace that back in. Don't forget your 4 over pi in the front part right here. Okay, and then negative 1 just becomes y from 0 to 1. Okay, so putting 1 into the equation, tangent pi over 4 results to 1 minus 1. So 4 over pi minus 1 minus this whole thing becomes 0. So 4 over pi minus 1 multiplied by pi, the pi cancels out. So that results in 4 minus pi, your final answer. Okay. Same goes for if this example. But right now, your y is equals to square root of cos x. So the square of the square root of cos x is just cos x. Then you integrate it to become sine from 0 to pi over 2. So this one's pretty simple. Now, what if there are two curves? One is, again, like just now, cos, okay, cos x, and one of them is sine x, and it's going to be rotated about the x-axis. So by using the identity, the question then goes on to say, by using the identity cos 2x is equals to cos squared x minus sine squared x, find the volume of the solid generated. Okay, from 0 to pi over 4. That means there's an intersection here. Okay, but what if this is not given? What if the intersection is not given and they tell you that it is bounded by the y-axis? So it has to be this volume right here. Okay, so that means you're going to have to look for this intersection right there, and that intersection is pretty simple. It is when those two this is x, those two curves are equal, when sine x is equals to cos x, and this is how you do it. Okay, so sine x is equals to cos x, the cos goes down, and that would equate into tangent of x. And remember daddy, tangent x, tangent of what is equals to 1? Tangent of pi over 4. So that is the intersection point. Moving on. Okay, again, back to this part of the curve then. Okay, so we've identified that this is the intersection point and it is pi over 4. Okay, so then you have to bear in mind that it is always the area towards the axis. Okay, so that means the one on top, when you integrate, the one on top has to minus out the one below. So the one on top right now is cos, sorry, and the one below is sine. So cos, sorry, the one on top is cos, the one below is sine. So cos has to minus out sine x. So cos squared x minus sine squared x, because, well, it's volume, so you have to square them. So since this part right here, the square is hard to be dealt with, okay, the question already said that you should be using this identity. So change that use that identity, change it into 2x. Now this 2x, again, you're gonna let u is equals to 2x du over dx is equals to 2. So substitute that, you're gonna get 1 over 2 cos sine, this should be sine 2x from 0 to pi over 4. This one again, it should be 4. Oh wait, yeah, it should be 4. So the 1 over 2 goes out. Okay, then you get your final answer. Next, now what if you are looking for the volume of a solid generated by rotating the region bounded by the curve y is equals to sine x. So I'm just going to quickly draw that. Okay, y is equals to sine x from 0 to pi would look like that. This here is pi. Okay, and this is y is equals to 0, which is your x-axis. Okay, that's your y-axis, and this one right here, your maximum point is 1, but it is being rotated about the line y is equals to 1. Y is equals to 1. So this thing right here is gonna rotate about this axis. So that tells you it is always towards the axis. So right now, this line is on top, this curve is below. So this line is going to minus out the curve of sine x. Okay, that's one. But then you also have to consider the fact that it is no longer sine x. This sine x has gone underneath the axis, which means it has gone down. So therefore, it is 1 minus sine x. Same goes for the paxi x. It is now 1 minus 0. instead of just 0. So 1 minus 0, the whole thing squared for this straight line right here. Whoopsie daisies. Okay, and then 1 minus sine x for this curve right here, the whole thing square. So again, kembang-kembang, okay, but since we don't want it to be in terms of other things, keep it in only when it is square like this, it's gonna cost a lot of trouble. So use identity to avoid those squares. Okay, so use this identity. Sine squared x is equals to 1 minus cos 2x over 2. This is another identity, you can check it out. Okay, then it would be a lot easier to integrate. You just use substitution for that 2x. That's why you result in 1 over 2 sine 2x. Okay, from 0 to pi, substitute those values in and you should get your final answer. Okay, so the next one pula, okay, it is going to revolve, it is sine squared x. I'm not sure how sine squared x looks like. I think something like that. Okay, but instead of revolving it on top, it's going to revolve below. And y is equals to negative 1. So who is on top right now? It is the curve. Then you have your straight line. So the curve sine x is going to minus out the line y is equals to 0. And this curve has gone up. So that means you're going to plus 1 to the curve, plus 1 to that straight line. Okay, so kembangkan. Again, there's that power 4 there and that power 2. So you're going to have to deal with that using identities. And again, more power 2. Again, deal with that using identities. So then you would get sine. Everything would be in terms of sine from 0 to pi. And that would be your final answer. Okay, so that's about it. Okay, please answer the next quiz that is coming after this video to complete your attendance. And if you have any questions, you can always come and see me next week or the week after. Otherwise, you guys have a nice day and Assalamualaikum.